The Amish are running gas mowers for 30 years on machines that cost them less than what you spend on one replacement. They are not going easy on them. They are not using anything fancy. They just understand something about small engines that the industry has spent 20 years trying to make you forget. Today, I am showing you exactly what it is. Ammon Koblenz runs an engine repair shop south of Leesburg, Ohio in Highland County. He repairs lawnmowers, snowblowers, mopeds, and small engines of every description. He learned his trade through a correspondence course. No internet, no diagnostic software subscriptions, no dealer network. His shop runs on one principle that the modern outdoor power equipment industry has been systematically dismantling for 2 decades. Every part in the machine should be something you can see, touch, remove, measure, and replace. That is the entire philosophy. And it is the reason his customers are still running mowers from the early 1990s while yours is sitting dead in the garage after 6 seasons. Here is what the Amish are actually doing differently. This is not a lifestyle piece. This is not nostalgia. This is engineering, broken down component by component, with the specific materials, the specific failure mechanisms, and the specific dollar amounts that explain why their machines outlast yours by a factor of 5. Start with the engine block. This is the foundation of everything. The mowers. The Amish use cast iron cylinder sleeves. Cast iron is far more dimensionally stable under heat than aluminum. It resists warping under normal operating conditions. It holds its bore geometry across thousands of thermal cycles far better than the alternative. When a piston moves up and down inside a cast iron sleeve 60 times per second at operating temperature, the sleeve holds its shape. The surface finish retains oil. The rings seat properly against the wall. Compression stays consistent season after season. When the cylinder eventually loses compression after many years of hard use, you do not throw the engine away. You take it to a machine shop. They bore the cylinder out by 10,000ths of an inch. They fit an oversized piston. They hone the new surface, and the engine gets a second life. On well-maintained engines, you can do this more than once on the same block. That kind of longevity is simply not possible with an aluminum bore. Now look at what is inside the mower you bought from the big box store last spring. Aluminum cylinder. Thin walls. Lighter, yes. Cheaper to cast, absolutely. But aluminum is softer than cast iron. It wears faster. It scores more easily when debris passes the air filter. And when it reaches the point of oil consumption and compression loss, which happens dramatically sooner than cast iron, the engine is done. There is no reboring an aluminum residential mower cylinder at the consumer level. There is no oversized piston kit available at your local parts counter. The engine is scrap. And since the engine and deck are often sold as one integrated unit with proprietary mounting configurations, replacing the engine frequently means replacing the entire mower. That swap from cast iron to aluminum saves the manufacturer a few dollars per engine. It costs you the entire machine in 6 to 8 years. The Amish know this. That is why every mower in Ammon's shop has a cast iron sleeve you can feel with your fingernail when you pull the spark plug and look down the bore. Next, the ignition system. This is where the 30-year gap between the Amish mower and your mower becomes almost insulting in its simplicity. The Amish mowers run points and condenser ignition. It is entirely mechanical. 2 contact points mounted on a plate inside the flywheel housing. A condenser the size of your thumb. A simple ignition coil. When the flywheel spins, a cam lobe opens the points at the correct timing position. The condenser absorbs the voltage spike. The coil fires the plug. That is the entire system. You can see every part. You can test the point gap with a feeler gauge that costs $3. You can replace the points and condenser together for under $12. You can set the timing with a screwdriver and a test light. The service life of that system, properly maintained, runs 25 to 40 years without question. A 16-year-old with a basic toolkit can maintain it. Ammon teaches his apprentices this repair in their first week. Your mower has a sealed electronic ignition module. It is a black plastic box potted with epoxy. Inside that box is a circuit board with solder joints, a trigger coil, and a transistor that replaced the mechanical points. You cannot open it. You cannot see what is inside. You cannot resolder a cracked joint. You cannot test individual components. When the solder joints crack from thermal cycling, the repeated heating and cooling that happens every single time you run the engine, the module dies. The typical failure window is 4 to 7 years. When it fails, you order a replacement. If the manufacturer still makes it, the module runs $60 to $100. If the model has been discontinued, and many are discontinued within 5 years of the mower going out of production, the part simply does not exist anymore. You are not maintaining equipment at that point. You are discovering the end of a planned service life that the manufacturer set before the mower ever left the factory. That swap from mechanical points to a sealed module saved the manufacturer an estimated $12 to $18 per unit at the assembly level. You're probably looking at your own mower wondering if it'll last that long too. Here's the thing, you don't need a 1985 machine to get 1985 longevity. You just need to know what they know. So before you waste thousands on repairs and replacements, check out the new maintenance protocol that keeps machines running for decades. Best part is it's not just a list of maintenance tips. It actually shows you what kills these mowers, how to spot trouble in your own engine before it dies, and which parts to buy without getting jerked around at the dealer. And it doesn't matter if you've got a walk behind or a riding mower, there's one for both. Plus, every book comes with a printable maintenance calendar and more. Scan the QR code or tap the link up top. Use code MarkTalksQuality for 15% off. Make it last. $12 to $18. That is what 30 years of potential service life was traded for. And unlike the points system, which fails gracefully, you can feel the timing drift. You can see the pitting on the contact faces. You can fix it in your driveway on a Saturday morning. The electronic module fails completely and without warning. It works until it does not. There is no diagnosis, there is no repair. There is only replacement if the part exists, or disposal if it does not. Now, the carburetor. This is the one that makes every old school mechanic in the Amish country shake their head. On the mowers the Amish run, the carburetor body is cast aluminum. Some of the older ones are steel. It is fully serviceable. You buy a rebuild kit for $8 to $15 from any small engine parts supplier. You pull the carburetor off the engine in 10 minutes. You disassemble it on your workbench. You drop the float bowl. You pull the needle valve. You remove the jets. You replace every gasket, every O-ring, every wear surface in the kit. You clean the passages with carburetor cleaner and compressed air. You reassemble it, set the mixture screws to the factory specification, reinstall it, and start the engine. Total time, 45 minutes to an hour. Total cost, $12. Ammon has rebuilt carburetors that have been in continuous service for over 20 years. Total parts cost across 2 rebuilds over 40 years of mowing, about $30. Your mower has a plastic carburetor, injection molded from a nylon-based polymer. Here's the problem. Ethanol blended fuel, E10, is technically acceptable for small engines according to the manufacturers themselves. But here is what they do not emphasize. E10 fuel degrades faster than non-ethanol fuel. Ethanol is hygroscopic. It absorbs moisture from the air. In a mower that sits in a garage between mowing sessions, the fuel in that plastic carburetor is slowly absorbing water, oxidizing, and depositing varnish in the metering passages. Over a winter storage period, that process accelerates dramatically. The lighter fractions evaporate. the heavier fractions turn to gum. And a plastic carburetor body is less forgiving of that chemical abuse than a cast aluminum one. The varnish bonds to the plastic surfaces in ways that carburetor cleaner cannot fully remove without complete disassembly. And fuel with ethanol content above 10%, E15, which is increasingly common at pumps, is explicitly not recommended by Briggs & Stratton, Honda, or any major small engine manufacturer. If you have been running E15 in your mower without knowing it, the carburetor damage is accelerated significantly. The typical failure window is 5 to 8 years. Many of these carburetors are not designed to be rebuilt. They are designed to be replaced as a unit. A replacement carburetor assembly on a modern mower runs $30 to $70. Add the labor if you are paying a shop and you are approaching 60 to 70% of the cost of a new machine, which means you buy a new machine, which means the manufacturer just sold you your third mower in the time the Amish are still running their first on a $30 carburetor rebuild budget. The fuel lines tell the same story. On the older machines, fuel lines are rubber nitrile or neoprene compounds rated for long-term fuel exposure. You can feel the difference. Pull a fuel line off an Amish mower from 1995 and it is still pliable, still sealed, still doing its job. On some modern consumer mowers, the fuel line material is a lower grade compound that degrades faster from UV exposure, heat cycling, and ethanol contact. When those lines crack and harden, and you can check yours right now by pinching the fuel line near the tank with your fingers, cracked fuel lines on a gas-powered machine are not just a performance issue, they are a fire hazard. If the line feels stiff or shows visible cracking at the fittings, replace it before the next use. Ethanol-compatible fuel line rated for small engines is available at any parts counter for a few dollars. And then there is the governor assembly. This is the part most homeowners have never heard of, but it is the reason your mower surges at idle and eventually loses power under load. The governor regulates engine speed. When you hit thick grass and the engine bogs down, the governor opens the throttle to maintain RPM. When the load drops, it pulls the throttle back. It is a constant dynamic balancing act happening hundreds of times per mowing session. On the Amish mowers, the governor is a set of steel weights on a steel gear driven by the camshaft. Steel on steel, precise, durable, adjustable with a wrench and a factory specification. On modern consumer engines, those weights are plastic. The gear teeth are composite. The shaft rides in a nylon bushing instead of a bronze one. Thermal cycling causes the plastic components to expand and contract at a different rate than the surrounding metal. Over 200 to 400 hours of operation, the gear teeth wear. The weights lose dimensional accuracy. A tooth shears. The governor can no longer regulate engine speed. That surging RPM you hear is not a tuning problem. It is a terminal diagnosis delivered by physics on a plastic part that used to be steel. The transmission is the next piece of this equation. Belt and chain-driven transmissions in pre-2005 walk-behind mowers have replaceable bearings, accessible drive components, and service documentation that any mechanic can follow. When a bearing wears, you press out the old one and press in a new one. $2 for the bearing. When a belt stretches, you replace the belt. $8. The assembly itself is not the consumable. The wear parts inside the assembly are the consumables, and they are cheap, available, and replaceable independently. On many modern mowers, particularly lower-cost self-propelled units, the transmission is a sealed case that is not designed to be opened in the field. The engineering rationale is noise reduction and weather protection. The practical effect on these models is that when the internal gears or bearings wear, and they will wear because they are mechanical components under load, the entire assembly must be replaced as a unit. No bearing swap, no rebuild. You purchase a new transmission assembly at $120 to $180, or you purchase a new mower. Not every modern transmission is built this way. Some higher-end and commercial models still offer serviceable drivetrains with published parts diagrams. But on the consumer floor models, the sealed case is common. Check the parts diagram and service manual before you buy any mower. If individual transmission components are not listed as separate parts, that tells you everything about how the manufacturer expects you to handle the repair. Here is what connects all 4 of these components. Every one of them followed the exact same path. A serviceable metal part was replaced with a sealed or plastic version. The manufacturer saved a few dollars per unit. Multiply that across hundreds of thousands of units per year, and those few dollars become tens of millions in annual savings. The service life dropped from decades to years, and the repair cost was engineered to hit the precise threshold, 60 to 70% of replacement cost, where buying new is cheaper than fixing what you have. The Amish did not discover a secret. They just refused to participate in that model. They buy the mower with the cast iron sleeve, the mechanical ignition, the metal carburetor, and the serviceable transmission. They maintain it on a schedule, and they hand it to the next generation. So what do you do with this information? You have 2 paths depending on where you are right now. If you are buying, the key is not the year on the mower. It is the engine family. Not all older Briggs engines have cast iron sleeves. Briggs has made aluminum bore consumer engines since the 1950s. What you want are specific engine families that were built for commercial duty. On the Briggs side, look for Vanguard, IC, Industrial Plus, or Intech Pro Series engines. Those are the lines that use cast iron sleeves. Do not assume that any Briggs engine from a certain year is automatically the durable version. Check the engine model number and verify the family before you buy. If you specifically want points and condenser ignition, the fully mechanical system we described, you are generally looking at engines built before the early 1980s. Briggs transitioned to solid-state electronic ignition starting in that era, and by the 1990s, most of their engines had electronic modules. That does not mean a 1995 engine with electronic ignition is junk. It means the ignition module is a wear item you should budget for, and you should confirm replacement modules are still available for that specific engine before you commit. Honda GXV series commercial engines like the GXV 160 use cast iron cylinder sleeves and are genuinely durable, rebuildable power plants. Honda ceased production of gas-powered walk-behind mowers in North America, so these are used market finds only. When you find a clean Honda commercial mower with a GXV engine, buy it. They do not come up often. One important note: Honda commercial mowers do not use points ignition or simple gear transmissions. They use transistorized magneto ignition and hydrostatic drive systems. They are durable because of material quality and engineering tolerances, not because they are mechanically primitive. Tecumseh engines are another option on the used market, but proceed with caution. Tecumseh ceased engine manufacturing in 2008, and part support was transferred to Certified Parts Corporation. Some parts are still available depending on the specific engine model, but availability varies widely. Verify that the critical wear parts, carburetor rebuild kits, ignition components, gaskets, are still in stock for your specific Tecumseh model number before you buy a mower powered by one. On the commercial end, used Skag and Exmark walk-behind mowers with Kawasaki FX or Honda GX engines represent professional duty construction with active parts ecosystems. These machines are built for landscapers running 50 hours a week. Your 10 hours a month will barely register on them. Realistic pricing on used commercial walk-behinds in decent condition runs from roughly $800 to $2,000 depending on age, hours, and condition. Clean examples with documented service histories command a premium. If you find one with verified low hours and maintenance records from a retiring landscaper, that is the best value in outdoor power equipment. The economics favor the durable machine over the long run, even when you account for the realities of used equipment ownership. A modern consumer mower at $350 with a realistic service life of 6 to 8 years before a major repair or replace decision means multiple purchases over a 20 to 30 year period. Each time you add disposal, shopping time, and the frustration of starting over with a new machine that has the same design limitations as the last one. A quality used mower with a cast iron sleeve engine purchased at an estate sale or from a retiring landscaper, maintained with annual oil changes, air filter replacements, spark plug swaps, blade sharpening, and the occasional carburetor rebuild will cost you significantly less over the same period. The exact numbers depend on what you find, what condition it is in, and what parts you need along the way. But the principle holds: one durable machine maintained on a schedule costs less than 3 or 4 disposable machines replaced on a cycle. Now, if you are buying used, you need to know what to look for and what to walk away from. Pull the spark plug and look down the bore with a flashlight. This gives you a rough visual check, not a definitive diagnosis, but a useful first pass. If you see clean crosshatch marks, the fine machining pattern from the original hone, the cylinder is in good visual condition. That pattern is designed to hold oil against the cylinder wall. If the wall is smooth and shiny, the rings have been riding on it long enough to wear the hone pattern away. That engine is still usable, but it is in the second half of its life. Factor that into your price. If you see vertical scoring, scratches running up and down the cylinder wall, debris got past the air filter and damaged the bore, walk away. For a more definitive answer on engine health, a compression test with a gauge tells you what the bore inspection cannot. A healthy small engine should produce compression within the range specified in the service manual. A compression gauge runs about $15 at any parts store and takes 2 minutes to use. That is the most reliable pre-purchase test you can do on a used engine. Check the oil, pull the dipstick or the fill cap. If the oil is black and thick, the previous owner did not maintain it on schedule. That is not necessarily a deal breaker on a cast iron engine. Those blocks are forgiving, but it means you are doing an immediate oil change and keeping a close eye on consumption for the first season. If the oil is milky or gray, moisture or coolant has entered the crankcase. On an air-cooled engine without a water jacket, milky oil usually means the mower was stored outside in weather and condensation built up inside the crankcase. That is recoverable with an oil change and proper storage going forward. If the oil has metallic flake in it, internal wear is already advanced. Walk away. Pull the air filter. If it is clogged solid with debris, the engine has been breathing dirty air, and you need to check the cylinder bore for scoring before you commit. If the filter is reasonably clean or recently replaced, the previous owner was doing at least the minimum. That is a good sign on a machine this simple. Grab the blade. Try to rock it side to side. If there is play in the blade, the crankshaft bearing or the blade adapter is worn. On most older mowers, this is a serviceable repair. A new blade adapter runs $15 to $20. But if the crankshaft itself is bent, which you can check by spinning the blade slowly and watching for wobble, that is a more involved repair. Not a deal breaker on a cheap purchase, but know what you are getting into. Start the engine. A healthy small engine should start reasonably quickly on a warm day with fresh fuel, a clean plug, and a properly set choke or primer. If it takes excessive cranking or will not start at all, that does not necessarily mean the engine is bad. It could be stale fuel, a fouled plug, a stuck float, or a dozen other fixable issues, but it does tell you the previous owner was not maintaining it, and you should factor that into your offer. Listen at idle. Steady RPM with no hunting or surging means the governor and carburetor are working correctly. If the engine surges, RPM climbing and dropping rhythmically, the governor may need adjustment or the carburetor needs a rebuild. Neither is a deal breaker on a mechanical system. Both are afternoon fixes with parts that cost less than $20. If you already own a modern mower and you are not replacing it today, you are not out of options. There are 6 specific maintenance steps that will push a consumer engine past the failure window the manufacturer designed into it. The intervals are not what your owner's manual tells you. They are shorter, they are specific to the engine type, and they address the exact failure mechanisms we just walked through. That is exactly why we built the complete maintenance protocol for this.